Hey there guys, in this one we're putting all of our skills with stationary points together and looking at finding their coordinates, determining their nature, and we're also going to include a little sketch of the function. Let's go! Okay, for our first example then, we've got y equals 3x to the power 4 minus 8x cubed minus 3. Now again, what we want to do is find the coordinates of any stationary points, classify their nature into a minimum, maximum, or point of inflection, and then finally we're also going to draw a little sketch of the function. So, first of all, to find the coordinates of the stationary points, we need to first of all differentiate to get the gradient of the function at any point on the curve. So let's do that. So dy by dx, well, that's going to be 12x cubed minus 24x squared. The minus 3 differentiates to 0, so it's all good. Okay, so at stationary points, dy by dx is equal to 0. So we set our expression for dy by dx equal to 0 and then solve that for x. So set 12x cubed minus 24x squared equal to 0. Now we want to solve this for x. So, numerically here, we have a common factor of 12. So the first thing we can do is divide that away. So we get x cubed minus 2x squared is equal to 0. Now we also have a common factor here of x squared. So I know it's tempting to divide that away, but don't, because if you do, you lose a solution. Instead, now factorize the left-hand side. So the left-hand side we can write as x squared times x minus 2, which is equal to 0. Okay, so now that we've factorized, we've set each factor equal to 0 and then solve those equal to 0. So the x squared outside the brackets now would tell us x is equal to 0, or the factor x minus 2 being equal to 0 would tell us x is equal to positive 2. Okay, so now we need to find the corresponding y coordinates to the x coordinates. So to do that, we substitute the x values into the original function. So when x is equal to 0, quite a nice one, the x terms disappear, So we would just get y is equal to minus 3. When x is equal to 2, well, y is going to equal, okay, so 2 to the power 4 is 16, 3 times 16 is 48, so then we've got minus 8 times 2 cubed, so 2 cubed is 8, 8 times 8 is 64, and then we've got the minus 3 on the end, so y is equal to 48 minus 67, which I believe is minus 19. So we can now say, so the stationary points are at 0, minus 3, and 2, minus 19. So what we want to do now is classify each of these stationary points. So we need to find the second derivative. Okay, so if our derivative dy by dx is 12x cubed minus 24x squared, d squared y by dx squared, well, that's going to be 36x squared minus 48x. So we now use this to determine the nature of the stationary points. So remember, if the second derivative is less than 0, so it's negative, then the point is a maximum. If it's greater than 0 or positive, the point is a minimum. If it's equal to 0, then we got a bit of a problem and we need to use a gradient table to determine the nature. So let's first of all look at when x is equal to 0. So when x is equal to 0, the second derivative, sadly, is equal to 0. So the nature of the point is indeterminate using the second derivative. So what we're going to do, we're going to use a gradient table to see what's happening to the gradient to the left of the stationary point and to the right of the stationary point, and then that will allow us to determine the nature. So in our table, we're going to have our x values going across the top. So we know that our stationary point happens at x equals 0. So let's put that guy in the middle. So that gives us a value for dy by dx, or the gradient, as 0. So at this point, the gradient is a straight horizontal line. There is no gradient here. Now, let's go one place to the left and see what's happening. So let's go for when x is minus 1. So if we substitute x equals minus 1 into dy by dx, well, we're going to get 12 lots of minus 1 cubed, which is minus 12, and then minus 24 lots of minus 1 squared. Now minus 1 squared is positive 1, so what we've got here is minus 12 minus 24. So that gives us minus 36. So what that tells us is to the left of the stationary point, the gradient is negative. So it's going down from left to right, like that. Now, we need to be careful to the right of this stationary point, because we know the next one happens when x is equal to 2. Luckily, there is a nice value of x equals 1 between these two stationary points. So, when x is 1, dy by dx is 12 times 1 minus 24 times 1, so that's going to give us 12 minus 24, which gives us minus 12. So on the right of the stationary point, the gradient is also negative. So this tells us that this stationary point is a point of inflection, because the gradient is of the same nature either side of the stationary point, so it's negative on both sides. So therefore 0 minus 3 is a point of inflection. Good times. Okay, let's now have a look at when x is equal to 2. So, when x is equal to 2, the second derivative let's have a look. What's that going to be? So it's going to be 36 lots of x squared, which is 36 times 4, so that's 144, and then minus 48 times 2, which is 96. So we've got 144 minus 96. So that is equal to 48, which is greater than 0. So 48 is greater than 0. So that tells us this stationary point 2 minus 19 is a minimum. So now, armed with this information, we can do a cheeky little sketch of the curve labelling the stationary points. Okay, so let's have a look then at how this helps us sketch the graph. So we're not going to be putting in the x-intercepts, only the coordinates of the stationary point and the y-intercept, which actually turns out to be at a stationary point, 0, minus 3. So first of all then, that stationary point 0, minus 3 is a point of inflection. So let's say that point is here. Now what we know is that to the left of this point the gradient is negative, and to the right of this point the gradient is negative. So we know the curve is doing something like this at this point. Now there are no stationary points to the left of this point, so the graph is just going to shoot on up to infinity. But we know then that our next stationary point is at 2, minus 19. Don't forget as well to label the points, something I always forget to do. Okay, so 2 minus 19 is a minimum. So let's say that's down here. So what's going on at a minimum? The gradient to the left is negative, and the gradient to the right is positive. So to the left it's going to look something like that, and to the right it's going to shoot on up to infinity and beyond. Make sure you label the stationary point down here. So that's 2 minus 19. There is a sketch of our graph with the stationary points labelled. Okay guys, I think that's enough fun for one video. Hope this has helped. If you want more, let me know down below in the comments. Take it easy, take care.